Carbon fibre reinforced polymers are the superhero of modern-day engineering materials. With an extremely high strength-to-weight ratio, these composites have a vast array of applications, including aerospace, military, car racing, and other competitive sports. Accurately designing for these uses requires a thorough understanding of their failure mechanisms. Composite failure is inherently difficult to predict due to the material's orthotropic nature, with complex interactions between the fibres and resin. Onset theory aims to analyse strain at a micromechanical constituent level, considering material properties of the fibre and resin as separate components. It predicts that composite failure will occur at this micro level due to one of two failure mechanisms: dilatation, i.e. change in volume, or distortion, change in shape. These two failure modes are governed by two critical strain invariants, which are considered to be intrinsic material properties. Experimental validation of onset theory currently covers a variety of load cases, including off-axis tensile testing and failure at different temperatures. However, little is known about its accuracy in predicting failure in compression. As such, this thesis aims to extend onset theory to cover composites in transverse compression. It has been broken up into two parts: a modelling phase undertaken in Thesis A and an experimental validation phase which is currently in progress. Modelling required the construction of representative volume elements which capture the nature of how fibres are distributed in the resin. Micromechanical enhancement factors are calculated through this process to allow the translation of macromechanical strains to micromechanical strains through onset theory. This was carried out in MATLAB. Note how E2 is negative here to account for a compression environment. The modelling results predicted a failure strain that is now to be validated through experiment. To prepare for testing, pre-preg composite is laid up, cured, and cut into rectangular specimens that are about 15 cm long and 2.5 cm in width. A strain gauge is applied, and the coupon mounted in a compression rig and compressed to failure. The critical failure strain will then be compared to that which was predicted through onset theory. Should onset theory be validated for this load case, in future it will allow for the failure prediction of composites in transverse compression. Furthermore, it means that the compression test could be used to calculate the critical distortional invariant, replacing the currently challenging 10-degree tensile test. Ultimately, this will lead to stronger and lighter sporting equipment, race cars, and planes. The possibilities are endless.